Well, sort of slightly curious talking to this audience about climate change, for God's sake. You know, most of the people in this audience should know vastly more about it than I do. But this is not a unique event, therefore, for a chief scientific advisor. By and large, given my arguably absurd job description of responsible for all science and engineering in the United Kingdom, this is not a unique event that I'm talking to a group of people who know rather more about the subject than I do. This is not to be unpleasant to you, but to say that I feel marginally less nervous doing this than I did when I was talking to a group of nuclear fusion specialists who are using lasers to actually generate fusion. That I felt slightly uncomfortable about, I have to say. Though here I am, in a sense, I felt I was going to be, to some extent, preaching to the converted. I suppose what I'm going to try to do this afternoon is to give you an idea of the sort of links at my level in government, because obviously of necessity many of these links are political. And in a sense that's a political aspect with small p, but quite quickly moves to the large P. And I think what I want to be doing is to put some of this in context and why I'm trying to, in a sense, deal with matters that you'll be discussing in much more detail later on. So let me go to the first slide, which is terribly familiar to everybody here, but actually it is enormously important to emphasize that that climate change is happening. It's not some sort of mad invention of the politically motivated Met Office, or indeed the unpolitically motivated Met Office bit. It is happening. The sort of data that we see, and I'll get onto it a little bit later, but completely extraordinary things happen. You know, a letter by the previous cabinet secretary making two claims. One is that temperatures was not increasing and hadn't increased for a decade, and I think the top right-hand graph is a reasonable refutation of that as a point, and also a completely extraordinary claim, and this was a letter to the Financial Times, that essentially the Arctic was back to normal. And it was that Arctic was the same as it was in 2007. Well, I think probably in the middle of winter that arguably might be true when you look at it from a polar bear's point of view. But if one thinks about the sea ice extent, as the bottom right-hand graph shows, 2012 was the sort of lowest sea ice extent that we've seen ever. 2007 was the second lowest. But, this is happening. Sea level data sets, and in fact the increase in atmospheric CO2 at Mauna Loa, all important. And indeed, again, to focus a little bit on the point that is that there is what I've termed a sort of saloon bar science world, which people like I have got to combat. It's the person who looks out of the window and notices that it's cold and says, oh, this global warming is rubbish, isn't it? Have another gin. And that's the sort of style that actually, unfortunately, is quite influential. And to an extent, therefore, one has got to be sober and analytical about dealing with these sorts of questions. But there's also an issue that where one is not dealing with that sort of saloon bar science, we also need to be thinking about actually convincing those who this is peripheral to their agenda. So I owe this to Tim Benton, who drew my attention to it. But this is some global temperature anomalies from 55, 65, and 75. All of you, this audience, will be very familiar with these sorts of data, with the red showing a significant positive anomaly, i.e. more warmer. And of course, the thing to notice as we move through 75, that the Canadian Arctic has quite a lot of red. And that's, a couple of decades between 55 and 75. And then again, like when I'd emphasize, this is all familiar to you, but when I'm presenting and having to deal with this with politicians, that is 2006 to 2011. And it's very dramatic. Now, whether it's statistically significant or whether in fact one has got an appropriate sampling regime across the world, matters in a sense less, because what one is looking at is something that visually comes forward and says, for heaven's sake, actually, guys, in the 2 decades between 55 and 75, there's quite a lot happened in 30 years since 1975. And this is enormously important in convincing both lay people but also politicians that something is going on when more detailed analyses, albeit much more rigorous, fail to do so. And I think that couple of slides is really quite important. The other thing which is really difficult to get over into government discussions is the thing that you're all well aware of, is that essentially the mean distribution is going at, that the distribution around a mean is actually going at about twice the rate. And this is some work that Hansen published last summer. And it's the June to August anomaly, and we'll get slightly different ones over different periods. But the sort of point that we're making here is that this is going to affect us, because what it is weather. And it's weather that matters to farmers and businessmen and the general public, not climate. And the weather distribution was showing that there are greater and greater variation that one is observing, and that variation is increasing at double the speed of the actual basic parameter, whether it's temperature or precipitation or what. And again, in the way that somebody like I has to explain it, I point to 2012 and say that 2012, as far as rainfall was concerned, it was an average year. And the fact that that average was determined by 4 or 5 of the driest months we've ever seen in a winter, followed by 7 of the wettest months we've seen for about 100 years, but it comes out about average, gets home to my political masters that these things are truly important. But the other thing that is really, and this is more difficult, is to do with was really the attribution. And I know this is statistically extremely difficult, but the sort of analysis that has been done here, which is shown in the big box, is the attribution studies that, that the chances of that Texas heat wave, which was extraordinary, occurring were about 20-fold difference over the period when climate change has been happening. And albeit these are terribly time-consuming, terribly hard to get right, these sorts of attribution studies are the sort of things that I would urge this community to think hard about putting effort into. Because it's, again, in a sense, it's a counter to our saloon bar friends. We can, let's take the top right hand. Scientists see a climate change linked to the Australian floods. Politicians see a climate change linked to the fact that it is extremely cold outside and it's supposed to be global warming. The intellectual content of this are almost identical. So these attribution studies, albeit they're very, very hard work and they're quite difficult to do, are actually really, really essential. And the other point that, again, seems to me to be enormously important, and I think this community has arguably understated it, because I'll pull out, and this is a familiar graph to many of you, which is the difference between the scenario uncertainty and the model uncertainty and the internal variability driven by the sort of chaotic dynamics. I think that the points here that really are worth dragging out are obviously the time delay, that we are looking at trajectories of greenhouse gas emissions, and that therefore our weather today was essentially determined by the accumulated emissions in the upper atmosphere 20 years ago, 20, 30 years. Beware spurious accuracy. And that's actually quite important for policy, because a lot of discussion is saying, well, actually, we're delaying an international agreement to 2015. We won't implement it to 2020. So in terms of actually the effect on greenhouse gases in the atmosphere, even if you'd got some form of cutoff, the accumulation is such that the greenhouse gases in the atmosphere when the international community eventually gets around to it, probably mean that weather is going to be determined out to 2040 or 2050. And that seems to me to be something that needs to be shouted about, because it's true. I understand that there's a reticence to do that because people will think that there is not, don't do it because it'll say it's irrelevant. We're doomed, so why bother about taking difficult decisions now? But those time delays are truly important, and I think that when we think about them and the urgency, I think we've the urgency of actually having this, particularly in the context that weather variability is getting much larger, we need to be thinking about putting that sort of picture together. I'm going to now focus on something which is a bit unfamiliar to this group. The things on the right, of course, are familiar to you. But the graph on the left is what is known as our National Risk Register. And this is saying what the risks to the United Kingdom are, looking 5 years out in front. And the x-axis is the likelihood of things happening, and the y-axis is the impact. And so, for example, the very top right-hand is the instance of pandemic influenza. A little bit further down, similar likelihood, lesser impact, would be a severe space weather event, or an explosive volcanic eruption, or an effusive volcanic eruption, and so on. But the ones I've circled, these are all the issues which are seen as genuine national risk to the United Kingdom. And the ones I've circled in yellow are all of them depending on weather, and obviously therefore ultimately on climate. And the direction of change of all of these four things, all of these risks to the country, are all moving essentially to the right and up. And I think that this is again something that the community in government which deals with civil contingencies have not actually focused on, and it really is truly important. And that is another way that we can have some degree of import in how we deal with it. And obviously the sort of climate related events, I've just taken a sort of selection of it, but the drought in the USA in 2012, one of the most severe for 25 years. Those of you who may remember was actually 2010 was the wettest year on record for the USA. And 2012, one of the biggest droughts they've had for many years. And other issues like that. But the point here I'm making is that if we think about our National Risk Register, which is developed with big consultation across the whole of Whitehall, thinking about where the risks are for the continuation and happy development of the United Kingdom, all these, there's 6 of them, all of these are determined by weather, and all of these are going to be affected adversely by making the probability higher and the impact higher. So this is the sort of way that, in a sense, people like myself need to engage at different levels with government. And then if the community, for example, could point to the sort of quantification of the increase in likelihood as climate change occurs, as weather moves, with the time delays that we're talking about, if there were a possibility that the science could be improved so that one could come up with the sort of an appropriate approximation to the length and direction of those yellow arrows, this would be something that would really gain traction, because ultimately governments survive and fall on what happens within civil society, and the civil contingency issues are really dramatic here. And of course, other things we need to think about are how we deal with the skeptics. This was the rather delightful conversion of Richard Muller, who actually, having come out, and I have actually collected a series of statements from Muller, which I won't, being kind and he's on our side now, repeat. But essentially, this was a man who was saying, this is complete nonsense, I will do it right. And you people in the climate world don't actually understand how to do statistics or modelling, and will do it. Pretty much the sort of point that Muller was making. But now, the dramatic difference between the Berkeley Earth assessments and the NOAA, NASA and HAD crew are would be take a little bit of enticing out to actually make that point. So those are this, but we need this sort of attitude because we have to deal with this nonsense and the media misinterpretation of results. I remember I was choked over my breakfast porridge on the Today programme when it was announced that the Met Office had now come out and indicated there was no climate change and that temperatures were not increasing. You know, I was sort of I have Julius Slingo on speed dial anyway. And so what on earth have you idiots been saying? But of course they hadn't been saying something. They've been doing proper and sensible analysis, taking into account the factors that actually affect predictions of temperature change out to 5 or 10 years, and actually a revision. So the degree of revision, which is shown by the sort of central thick blue line with the confidence regions around him, indicate, you know, this is not a big deal. But look at what the good old Daily Mail Online says: crazy climate change obsessions that made the Met Office a menace. How do you deal with this? The answer is you have got to deal with it analytically, calmly. You know, I made a joke just now talking to Neil Morissetti, who's our climate change envoy in the new climate change envoy in the Foreign Office, that, you know, I don't think it's going to help cutting them dead in my club, you know. It's not, you have got to think about how we address this. And this is the sort of thing that we will continually get in terms of sniping, but we have got to gear up to do it and gear up to address these issues. And one gets weary. You get weary of it. This is not the science that we signed up to do, but we got to do it. So in the last couple of minutes of my talk, I'd like to point to a couple of sort of obsessions of mine, which are things that are going on. And the basic obsession that I have is that, to a good approximation, the next 20 or 30 years are already determined. Now, we've talked about the time delays in the climate system, but there's a couple of things that are also determined. One is demography, and one is urbanization. So between now and 2025, as the top left-hand graph shows, there's going to be another billion people. So 12 years away, there'll be an additional billion people on the planet, of which 500 million will be in Africa, 500 million in Asia. Africa will essentially increase by 50%. Asia will go up from 4 billion to 4.5 billion. Massive increase, almost breathtaking to contemplate. And the urbanization trend, the top one, points to the fact that 2010, the urban population exceeded the rural. Almost all that increase that you're seeing in population will be in urban environments. And to put something on this, again, 12 years, that's all. And there's, you know, demography, it might not be 2025, it might be late in 2024 or early in 2026. Beware spurious accuracy. But you are seeing there will be another 500 million people in Africa, and they'll largely be living in cities. And to give it a sort of parochial flavour, I point to a fact that, give or take, there are about 500,000. It would be the expected size of of an average city. So you're talking 1,000 cities the size of Edinburgh, occurring in Africa in 12 years. Now, that is massive. And then there's issues to do with vulnerability, because demography is well determined. We know that there are going to be a massive increase in the more vulnerable parts of the world, particularly more vulnerable people over those aged over 65. And migration to coastal cities in particular means that vastly more people are going to be exposed to hazards, particularly weather and ultimately climate-driven hazards. So that's the sort of problem that I'm worried about, and puts it into a broader context. And if you put that in the context of demand for natural resources, the top left is world energy consumption, and the projections that's manifestly not much of an expectation increase in the OECD, but that non-OECD, massive increases expected in energy consumption. Big issues to do with water security, big issues to do with food security, give or take, a very, very large shortfall in terms of the availability of water and the ability to actually increase yields. Give or take, if you put that in the context that, in effect, we have about somewhere between 1 billion and 1.5 billion people currently who have insufficient food or insufficient access to fresh water or no access to available energy in terms of electricity. That's the sort of changes that are going to be happening. And they're the changes that are going to be driven and complicated by and made vastly more threatening by the fact that climate change is happening and that weather are doing it. And again, I'd emphasize that because of the time delays, there's nothing we can do about this. You're going to get another 1 billion people. You're going to find they're all living in cities, and you're going to have climate change and weather change is driven by that climate change because of what's up in the atmosphere now. So being prepared for it and recognizing that you've got to operate and think about those risks is really important. And finally, looking a bit further ahead, I think there's two really important turning points that we're looking on. And the first one in population is that predictions, the central line, red line on the top right-hand graph, is the most likely scenario, which shows essentially an asymptotic population of about 10 billion. But that's on a very strong assumption that fertility rates fall from what they are at the moment. If there was no fall in fertility rates due to prosperity, better education of women, better availability of contraception, you will be at a tipping point where you'll go way above that 10 billion. And that tipping point is going to be occurring because of the time delays in the demographic system. That tipping point's within the next 20 years. And we know how to do it. It's prosperity, it's the education of women, and it's the availability of contraception. And so there's a real tipping point in population, something for you lot to think about rather than just weather or climate all the time. Very important. And of course, we are looking at the potential of tipping points, and in the time I've got, I don't want to go into that, but highly likely that if we don't see some form of reduction in greenhouse gas emissions within the next 15 or 20 years, that some of the tipping points that we've been worried about are going to actually happen. And so the challenges are looking at to 2050, 2.5 billion more people, 70% of the world in urbanization, big complexities in terms of migration and demographic trends, and the basic requirements for food, water and energy, massive, and then emissions without any policy change going up about 50-odd%. So this is why it's important, and why it's important for, in a sense, people like me to engage and be prepared to focus on some of these really, really difficult issues. And in a sense, part of my job is to work with a community like this to explain the dangers, to explain the implications of a failure to agree a reduction in greenhouse gas emissions and a continuing failure over 5 or 10 year periods. So that's the job, and I hope, I wish you every success in your endeavours, because we really need it. Thanks for your attention.